All right, so I said good morning. Somebody's supposed to say it's not morning. Hey, Brian, how you doing? And I see all of the invisible people in the room have filled the room completely today. This is a great opportunity. I appreciate you joining us. So I work for EMC. I run strategy for the Emerging Technologies Division. Anybody who was at the keynote this morning probably saw my boss up there talking about what EMC is doing in the space and what we're attempting to accomplish and help in the industry. I thought it would be a really good idea, though, to kind of double click and get into some of the differences with how you can architect a solution for Hadoop and why it might be better in some cases. And we'll talk about some of the cons of doing it as well. My goal is really just to get you guys comfortable with the concept that things are able to be now a little bit different than they had been before. So what is a disaggregated Hadoop stack? If you think about Hadoop, it's all been about simplicity, put everything in a single box, add another box, add another box, add another box. Just keep adding boxes, and at some point or another, you've got everything that you need. And if your workload grows, you just simply add another thing. And the clicker's not working. Let's see if I walk over here. It's not going. Hang on, technical difficulties. Did we break? This worked in the rehearsal, I'm telling you. The clicker worked. I'll just kind of talk then while we're waiting for the slides to come up. So, what the next slide shows is the history of EDW. So anybody in the room has an EDW today? There's two, great, so everyone else is lying. So the EDW started out because we had databases, different kinds of databases. And those databases were all kind of put into your environment, usually because an application required that database. It's not working. Oh. We'll see if they can fix it or not. So the databases were created by different tool sets. So for example, let's say somebody put in Siebel as a front-end application. What was the database that came with Siebel? Oracle. Somebody put in Microsoft CRM or Dynamics. What came with that? Microsoft SQL, right? If you put in a web interface in the last maybe 5 to 10 years, you were probably using MySQL. And if you're an IBM shop in any way and you had various maybe legal applications or financial applications, you're probably using DB2. And the challenge with that is that you could never have centralized all of those databases into one infrastructure because every database did something really specific. And the data came in, they formatted it into a context that was only available for that particular database type. So the EDW got created. I want to start looking at context across all of my different databases. Everyone agree with this so far? Even though you can't see the slides that are really pretty and make it show that. So that's sort of the slide. In that context, what we had the problem was the database created a specific way. Here we go. Thank you, guys. IBM DB2, Microsoft SQL. I'm just catching the slides up to where I'm at. And we were pulling it into all of these things, like pull it into Excel, tried cross-correlation between different databases, and ultimately I end up with this answer. But it was so complicated that it made it a lot easier if I just simply took all of the data sets, replicated them from where they were originally housed into an EDW, and ultimately look at some different dashboard, BI tool, whatever. So far, everyone agree? Yep. It's really how the EDW came to pass. And what we found out is that by putting all of data into the tool set, we ran into a bit of a challenge. And that challenge was cost. The EDW that they sold you, they were now in control of the outcome of your data, and to that point, you got to a problem where now all of the data was stuck in that format. So what we do? We said, hey, let's take all the data and push it into Hadoop first. We'll still take some of the context out of Hadoop, but we'll do the ETL process inside of Hadoop. We'll make it so that there's less information having to go into that very expensive EDW solution. And that was really how Hadoop really got off the ground, right? A lot of customers, this is where the starting point was. So inside of those Hadoop stacks, these aggregated Hadoop stacks, are these different providers of them. So whether it's IBM, Pivotal, Hortonworks, Cloudera, or others, when it comes to Hadoop, traditionally what you're doing is buying the entire stack of network storage processing, memory, the operating system, JVMs, HDFS, and then some set of tools. So if you're IBM, for example, maybe you're using Watson or Big SQL, you're using some of those front-end applications. If you're doing something with Pivotal, you're going to be looking at Hawk or Gemfire or some of the applications they've built. And with the Cloudera, for example, maybe Impala. But the point is there's different tool sets available in these different solutions, so you're able to start utilizing those solutions inside of the integrated stack. Now, we do a little bit differently, and I say we, but there's actually quite a lot of solutions out there that do this, is when you swap out and you push HDFS into a new layer, you put it at a disaggregated layer, now the data is actually shared amongst multiple different tool sets. So is anybody in the room using Splunk, for example, today? A couple people. So if you're using Splunk and Hadoop, there's a bit of a challenge. Now, if you have data in Hadoop already and you want to use Splunk against it, they've hunk for the purposes of getting content and utilizing it inside of Splunk. But if you do it the opposite direction, I've ingested all of the information into Splunk already, and now I want to run Hadoop against that raw data that's already sitting in Splunk. How do I do that? The data is in a completely different architecture. It's been siloed into that particular tool set. If you put it into a common repository that speaks both to Splunk and to Hortonworks, for example, then now I can say data comes in through an interface on Splunk. I utilize it for that Splunk operation, but the raw context is now available to whatever I want to run in my Hadoop cluster. Does that sort of make sense? As a result of that, I have what I call a true data lake. I mean, a data lake not necessarily specific to Hadoop, not necessarily specific to Splunk or what anybody else might want to define as a data lake, but truly an open solution where I can have multiple tributaries, pardon while I take the pun even further, multiple tributaries of data sets coming in through different particular interfaces and multiple different use cases, whether through Hadoop use cases or non-Hadoop use cases. So I've got customers, and I'll tell you a quick story. I've got a customer who is a really, really big partner with SAS. And they have a SAS grid it's a big retail company. They have a SAS grid, and SAS grid allows you to run a bunch of parallel statistical analysis against data sets. It uses NFS for communication. Now, everyone in the room probably has tried NFS on Hadoop, and kind of sucks, right? Right. So being honest. NFS on Hadoop is a little bit slow, it's really problematic. So if you said, hey, let's do SAS grid against Hadoop, they're probably a bad idea. But SAS itself is starting to write some of their applications to speak directly to Hadoop. Not all of them are there yet, but if you wanted to run all of the SAS applications combined, you could run SAS grid against a parallel NFS connection that also speaks Hadoop, which means the data sets are shared across all of these different solutions. So, horizontally integrated versus a vertical stack. As opposed to having everything inside of a single chassis, instead of having to choose a single server and have one box and have everything in it, you can now separate out the storage infrastructure from that, and it provides you all of these different flexible and changes in how you would actually modify your data. You also have no more migration. So I'm sure a few of you guys have started out on one distribution and ultimately went to a different distribution, and during that process it's either a heavy migration or at least a heck of a lot of special engineering to make it all work. If you put all the data into a centralized infrastructure, you can run one distribution and then convert to a different distribution, or potentially run both of them at the same time against the same data set. So if you're in the process of doing a migration, then you just simply set up the other stack, test it, and then you've got everything kind of working. So in that technology stack, like we talked about, you build one box, you put a second box, you're growing everything together. And like I said, the great thing about it is simplicity. You take the box, you put the next box in, put the next box in. And that's not necessarily a problem as you have a smaller environment, but as you get to a larger environment, what you find is that the actual utilization of that is completely different than what you actually bought. So for example, I've got a lot of customers who have told me things between 4% utilization on their processors, 12% utilization on their processors combined. And typically what's happened is because of things like 3x replication and some of what I would consider to be deficiencies in HDFS, it's gotten to the point where it's gotten bloated only on the storage component, only on that physical spinning disk component. And so as a result, you have all these other things that are underutilized. When you disaggregate the stack, you have the opportunity to utilize exactly what's needed and grow each individual thing independently. Now, what my company is specifically trying to do is to separate and give you the ability to grow each of those independently, so that as you reach a scale where you need to be more efficient with your implementation, you can buy a memory chassis, for example, that will allow you to increase your memory footprint for all of the cluster, as opposed to having to go through each individual node and add a little more memory, or maybe that node can't take any more memory and you have to add more boxes just so you have more memory. Those kinds of things we're trying to figure out how to provide you that intermixed, interwoven opportunity for a disaggregated stack. So a real customer example. So this customer was a financial services company, a big bank. They had, we did an analysis with the organization, went around to all of the different groups and said, hey, what are you guys doing with Hadoop? So you go into the consumer side, go into commercial banking, all these different places, and every single one of them was playing with Hadoop, which was amazing, right? To see all these different divisions all kind of have something going on. We found was 19 different clusters. They had about 27 different divisions, 19 clusters running, and of those 19 clusters, 6 different distributions. Actually, it was 7. Intel was actually in there, but that got pulled out. So 19 different distributions, or 6 different distributions against 19 clusters. One of the data sets was replicated because of the triple replica 57 times. So one customer took their financial transactions, their credit card swipes. Every time you swipe your credit card, it goes into a IBM mainframe. The IBM mainframe guys were like, hey, people keep asking us for a copy of this data. We're going to replicate it to this one, replicate it to that one, replicate it to that one. When they started dealing them out to all these different 19 clusters, it ended up 57 copies of content. And you're like, well, this is just getting ridiculous. But the challenge was that you started getting into this political warfare, religious debate. So we need to start standardizing on a single Hadoop distribution. Well, the banks are saying, well, hang on, no. We have to have 2, right? It's our policy. We don't just have EMC for our storage, we have EMC and NetApp. Or we don't just have Cisco for our servers, we have Cisco and HP. And they went through this whole thing about how we are a dual vendor strategy and we will not allow anything in here that's not dual vendor. So what are the 2 vendors? Let's put the 2 vendors in, start talking about the replicas again, and all of a sudden they said, well, hang on, you want 2 Hadoop implementations with all of the same exact replicated data. At triple replica means you're at 6 copies. And by the way, we require a DR site. So now we're at 4 of the total implementations. 4 times 3, 16 copies, or 16 total capacity. It was starting to get to a point where even they couldn't figure out what to do. So we ended up helping them out was putting in a erasure-coded underlying storage system that would allow all of those distributions to maintain what they had. And they're going to slowly now migrate to the 2 from 6. Okay, so as that customer kind of went through a process of determining how their growth rate was happening in a traditional system versus what a disaggregated system would ultimately look like, this was how they built out their sprawl systems. This is actually a slide that they helped us work on. This is based on the number of rack units that would have started. So it was 44 rack units for their DAS environment in one of their facilities for a 50 terabyte data set. When they added up 10 of those data sets, it was 500 terabytes and 252 rack units versus 44. The big thing was that they ultimately said, hey, we need to go to about 50 petabytes. And what does that 50 petabyte look like? And it was quite significant. So what we realized through that conversation was that disaggregated meant a really big deal. Now, part of it was because of this challenge. The customer had all these card transactions coming through on a daily basis. Well, that daily basis was 15 terabytes of new content on a daily basis. They were processing the information, they were putting it into HBase, and ultimately they wanted to run some calculations against it, but the amount of performance that they're actually using was very small against the data set over a period of time. problem is they had a legal retention requirement. The legal retention requirement was they retained that data for 7 years. So the fact that they pulled it meant they had to keep it. So I've got 7 years of retention. So now 7 years of retention at 15 terabytes of new content per day, with very little being done on the historical content, at least today, meant that they were planning on 40 petabytes of usable, 50 petabytes in a disaggregated stack, 150 to 200 petabytes of data in a Hadoop stack. And at some point or another, actually, Hadoop was falling over when they got to around 30 to 40 petabytes. The name node just couldn't keep up with the amount of data. So they were talking about having to build 3 or 4 different clusters to support the system, when all of this really could have been done in a disaggregated stack by having everything inside of a centralized repository and reducing all of the copies and replicas, et cetera. So at the end, the customer just couldn't afford it. So with that in mind, we talked earlier in the keynote about if you were Google or for Yahoo, and maybe some of you are Google or Yahoo. I never thought about that. You have a lot of money. To give you an idea, Google built that beautiful data center there on the water that allows them to cool the data center using the water off the shore there. They have all sorts of very exciting ways of handling it. They have actually a walkthrough you can go to at Google, and they'll teach you about how they built their facilities, and they're intended to try to share the information about how they built the facility so that they cool the number of nodes that they're using for their GFS farm. But their GFS farm is massive, right? The amount of content in Google is bigger than I have in my data center. A little bit bigger. So the costs become data center space. I have a customer who came to me and said, hey, I've got a problem and I think you guys might be able to help because we do erasure coded calculations instead of triple replica, so we can probably reduce the amount of capacity for this particular customer. They say, hey, we ran out of space in our data center. Our data center, we had 2,000 Hadoop nodes. We were looking to go to 4,000, and the data center said, no, we can't get any more. So can you help us? Because we want to take a certain amount of the data set that's now archived state. It's data we don't care about in Hadoop anymore, but we have to retain it, legal retention again in this case. Can we archive that off onto your cluster and free up any space? Well, sure, actually. We're going to take 10 racks and reduce it down to a single rack. Because in a single rack of EMC, we give you about 3.5 petabytes of capacity, usable capacity. So pretty significant difference since we're able to pull all these different racks out of production. Floor space becomes very important, actually costing that floor space, the rack space, the actual physical racks, cabling infrastructure, of course, electricity and cooling. And those are 2 different things. A lot of times I'll talk to people about electricity costs and how much it's costing them to run their equipment. And they'll do calculation. I've got a 300 watt or a 600 watt server, whatever it might be, and that's going to equate to such number of kilowatt hours per machine. And I do the calculation times machines, and okay, here's my kilowatt hours, and I'm paying 12 cents or 15 cents or whatever it might be per kilowatt hour, and so here's my number. And there's a really cool calculation out there that'll go through a little bit more complexity, but as simple as this is, for every kilowatt hour a machine pulls, you have to have about a kilowatt hour of cooling. So basically doubles your electricity cost just to run a single machine. So when we started looking at the costs of bringing down 6,667 rack units down to 600 rack units, the biggest difference in financial price was electricity and cooling on that capacity. So I told myself I was going to make sure I didn't make this a pitch because it's really not intended to be a pitch. I actually believe that there's some really cool disaggregated stacks out there. I think what Red Hat is doing with Gluster, what IBM does with GPFS, what we're seeing Nutanix and other providers come out with, I think is actually really cool. I'm excited about it as a technologist. But I happen to have spent most of my time working on what we're doing with Isilon, so I'm going to use it as an example. This is a great example where we have a customer who's got Hortonworks and IBM Big Insights and Splunk. And today those are 3 different clusters. We're moving them all together now into a central Isilon cluster to put all of the data into a central place, disaggregating the stack, having all of the content live inside this single system. Polyglot communication becomes really important at that point. The ability to have all of the different interfaces that bring data in, bring data out, utilize that content for any particular distribution of Hadoop or non-distribution of Hadoop. We also have things like SMB having this act as a customer repository for things like your Word documents, Excel documents, PowerPoint, put all of that data in, and then all of the metadata, all of the actual physical data inside of those documents becomes available in Hadoop. We've had lots of opportunity where HR departments have come to us and said, hey, can you do a search and see if you find anything fishy inside of our all the metadata and all of the actual physical data for our file system? Because we have a feeling that people are storing things like resumes was a good example. Could we determine by looking at the before and after of a document that is titled resume if it's been changed? And if it's been changed, could we turn that into a signal that that's something we should look into? And it's surprising how many of you guys will store your resume on the company file system and make changes to it there. But it's actually pretty significant. SFTP is another good example. A lot of customers are talking to us about, I've got a mainframe, and I need to pull the data out of the mainframe and put it into Hadoop so I can run calculations against it. Reality today is you get that pulled out, you put it into a staging area, you copy the staging area into Hadoop. Now, that's not necessarily that big of a deal. It's kind of a double hop process, but it might take some period of time, especially given the amount of data you might be generating on a daily basis. One of those customers we were working with was taking about 24 hours to get the data copied the first time, and another 24 hours to get it copied the second time. It was some 100 terabytes, I think, of data per day that they needed to copy over. In that process of copying data out of the mainframe, because we were able to give them a direct SFTP connection, keep that secured connection, they dropped it directly into the Isilon cluster, and then we ran Hadoop directly against the data. We took 24 hours off of their total operation. What ends up that they were using this for fraud analytics, and it was a credit card company, and that fraud analytics, secondary fraud analytics, was going to save them over $100 million by simply cutting 24 hours off. So it was a pretty easy decision to make. So sometimes it's just a matter of figuring out, can you cut hops out of the process to make it so you get to the best answer? And sometimes a disaggregated Hadoop stack is one of the ways you can do that. I'll throw out an example of something that we do that's a little unique. Tiering is coming out in Hadoop now. We do tiering a little bit more unique, I think. When a policy is met, for example, a file reaches a certain period of time, it hasn't been touched, the A date is changed. And we can do it, and any kind of piece of metadata can be used for deciding when we're going to move data. The metadata stays clustered across all of the nodes, but the actual blocks of that data move to a different cost of tier. So you can have really, really high speed flash-based tier access to the data. But if that information hasn't been used in 30 days or 90 days, or whatever that policy you set is, we can move it down to an infrastructure that's a little bit less costly. We've released new architectures that store massive capacity. This new massive capacity is 350 terabytes per 4 rack units. So significant amounts of usable capacity per rack unit. And the same idea, now if, let's say you have something that's 2 years old and it hasn't been touched, Hadoop hasn't used it, and you want to move that into a different tier, we can also do that migration of the blocks without actually having anything impact the environment. The cool part is the entire infrastructure, all of the metadata, all of the data is all available to the infrastructure. Hadoop can still run against the data, and it's still available and live, but it's actually archived to a much cheaper, less expensive system. We're releasing at the end of the year something I think is pretty cool, is we're going to make it now so that you can not only tier within the actual physical environment, we can tier off to a cloud architecture. So say, for example, you want a cost point that is a glacier pricing. I think Amazon was recently saying they're going to try to get down to zero cost to store on Glacier. If that's true, then I think a lot of you guys are going to want to store stuff on Glacier. With that in mind, we wanted to make it so we could enable that. Be able to take data, tier it off to Glacier if it becomes a price point or something that you just don't need readily accessible in your data center or for your Hadoop cluster. Now, I believe that everyone has a different way that they're running their business, a different thing that they need to do. I believe Isilon is great for a lot of the traditional enterprise customers. We've got 6,000 of you guys. My guess is that probably most of you have Isilon in your environment if you're here. But it's not the only environment that you need to plan for. In a service provider context, where you have a geo-distributed environment, Perhaps, for example, you're needing to collect IoT sensors from across the world. The data really should come into the local point of presence as much as possible, but you need to maintain a single namespace for all of the data that comes in, regardless of what location it comes in. So we have a solution, and there's other solutions on the market that do this now. I personally believe there's a big gap in the Hadoop world, and the fact is that this gives you a geo namespace, multiple points of presence. You can put data into one location, it instantly becomes available to the other locations, and we distribute the data across all of the different locations. As a result, now you can get decision analysis across multiple geographies, and we can even do things like maintain separation of content when needed. Give you an idea of what that kind of looks like. You literally have a FQD and a fully qualified domain name. You point to that, it's going to go grab the local point of presence based on the hop count from you. You set up multiple different sites, and all of those kind of front-end, top-line applications are available to it. Now, Hadoop, in this case, sits on the outside of this and points into that data and can access it. This is a multi-exabyte container, and you can grow it to really as large as you need to grow. It's also a multi-tenant container. So in a multi-tenant container, you would say, as you're writing an object, the metadata and the security stays within the object. So if you're a service provider who maybe has 1,000 different tenants, well, those 1,000 tenants can all write their data simultaneously to this cluster. You can run Hadoop against the data sets and maintain the security and permissions without having to worry about the growth of the file system or getting to a point where you have to span multiple locations. So having a system that can give you a cloud scale infrastructure, especially if you're a service provider, is something that today doesn't really exist in the Hadoop community, and it's something we're trying to help revolutionize. The third one I don't have slides on because we're not allowed to show anything on yet, but we did talk about it this morning, is something called DSSD. This is taking Flash to the next level. We believe that Hadoop has the opportunity to run at much faster scale than it is today. And so we threw out this new product that's being worked on by Andy Bechtolsheim and Bill Moore, who originally at Sun. They created a new system specifically built for Hadoop that's going to take the IOP count of a traditional rack of Hadoop from 25,000-ish IOPS per rack to 15 million IOPS per rack. So the concept is if you have a very complex algorithm, which we're starting to see more and more complexity in the algorithms, being run against a data set, we'll be able to drive the actual result of that data set in a period of time that actually makes sense. I met with a customer in Australia a couple weeks ago, and it was a very interesting conversation. It was a university. University said that they're running into this challenge. They've got a big Hadoop farm. The challenge is that they have a student who needs to do something against the HPC cluster, Hadoop HPC cluster in this case. They run their job, and the job doesn't complete for the entire semester. So the student goes, and they never actually got the results of what they were trying to accomplish. So a bit challenging. And so ultimately, they determined that the bottleneck happens to be the spinning disks in the environment. They didn't have enough, but they couldn't also afford to grow to the number of spinning disks it would take to get the number down. So they're one of the great candidates for us to talk to about getting that extra performance increase. All right, so I think one of the biggest concerns people have when we start talking about disaggregation of the stack, people think, well, if I separate storage from my compute infrastructure, I'm going to slow things down. I have not seen that to be the case. I have actually seen the opposite, and I wanted to show you some of the things we've worked on with other parties to determine how that is. So for example, IDC did an independent study. They compared NFS writes and reads. I already said earlier that I think NFS on Hadoop sucks, so this proves it, because we have significantly better performance on our nodes, and we were running at the slowest possible node that we have in our environment. And that's 420% faster just on writes, and 3,600% faster on reads. Now, on the actual Hadoop jobs themselves, we ran some tests using the Terra family. So the Terra Gem, which really creates writes, the Terra Sort, which does a full MapReduce job, and the Terra Validate, which is more like a search. We did those three different systems. We found that generically speaking, a disaggregated stack can be a lot faster. Now, People often ask me why it's faster, and I think we've determined the reason why, and some of it just comes down to the way that things are written in our environment, which is 8K block size. So if you take a single file and you write it in 64 megabyte chunks, then it's going to be only on a handful of disks, depending on the size of the file, of course. But if you take a file and you write it across with 8K blocks, it could be written against hundreds of simultaneous disks. When you go to read that now, I've got to produce an 8K read from potentially hundreds of span disks. I'm going to get a faster read out of that than I'm going to when I pull up multiple chunks. That's the best guesstimate we have as to why there's better performance in our particular environment than against HDFS. But sometimes it's just going to be the latency in the network, the write process. Write process is especially latent. The time that it takes to get the first copy written to the second to the third, and then ultimately write that CRC back and let us know that we've completed the write on HDFS is a significant performance disadvantage. Another third party did the same validation, came up with the same answers, so it just kind of proves that two different validations done by two different independent parties both had the same information. And then finally, we did TPC-DS workload comparison. So with TPC-DS, this is an average number, actually not an average, this is a total number. We took all of the TPC-DS queries, we added up all the time that it took to do it on a DAS environment, all the time it took to do it against a disaggregated Isilon environment, and we showed the entire stack. As you can see, if you ran every single query simultaneously, basically this is the number you would show. Now, with that in mind, you guys probably don't run all those queries. I don't know that you know the answer to this, but if your query looks like any particular one of these queries, this is the actual TPC-DS query list that was run. So in TPC-DS, it runs something like 111 different queries, and then there's comparisons done between the two queries. Now, I didn't show all of them just for sake of space on the actual slide, but this gives you a good idea. And there's a couple different ones where Isilon showed significantly slower, for example, 28 and 58. So if your queries that you're running against Hive are similar to 28 and 58, then I would suggest that you probably keep it with the DAS environment and everything's working fine. But if you want to speed up your performance on the other queries, then potentially disaggregating the stack is going to give you better performance. All right, just to kind of sum up, these are the stories. I've got a ton of different customer examples. Talk about freedom of choice, not to get into the religious debate about freedom of choice, more of just say freedom of choice and the extent that people want to be able to use whatever tool they want to use. So if there was one thing I wanted you to take away from this talk, it'd be careful about putting your data into your tool set. Because over historical periods, that has proven to be a problem where you have to migrate, move, copy, replicate the data in order to get it into the next tool set and the next tool set and the next tool set. If you instead look at keeping your data raw, in a raw format, and allowing all of your tool sets to communicate with that data, it will change the way that you think about managing your content over time. It'll reduce your operational headache, your costs, everything across the board. So with only a few minutes left, I did want to open it up. I actually really love questions because questions seem to spark better, pardon the pun, spark conversation. So if you have questions, please let me know right now.
Hi, thank you. Thanks for the interesting talk. A question on the disaggregated market for Hadoop. How big is it? What's your growth projection?
Yeah, that's a great question. So the question is, what's the size of that disaggregated Hadoop market? So I think 2 years ago, it was 0. And when we first started getting some footprint, it was very small. Where we're at today is we've got about 800 active customers from an EMC perspective. I know that Gluster and GPFS and others have some market share. From a total percentage, we estimate it to be right about 15% of the total Hadoop market today. But from 0 to 15% in 2 years, we're actually thinking that it's going to start to continue to take market share over the next few years.
So are you saying it about 15% growth?
Yeah, 1.5, about 15% of the market share today is running disaggregated in our estimation.
Oh, it's already 15% in the last 2 years. Oh,
Yep.
That's a great one. Another one was on the calculation when you're doing it, the optimization of disaggregated versus DAS. What is your benchmark was in terms of Are you saying it's 16 different distro sharing it?
Yeah, there was
That's where it was coming up, that number, or?
yeah, there was 19 different physical Hadoop implementations. There was 6 different versions of Hadoop. So that the version of Hadoop didn't really matter, except that you can't all pull them into one.
That's right.
And then finally, there was 57 total replicas. So if you took the 19 Hadoop installations at rep count 3, with it was basically 19 times 3, and then there was the original copies that they had started with in the first place, and then some landing zone copies and things like that. So the total count came out to about 57 copies.
Thank you.
No problem. Thanks. Yeah, so real quickly, the question is about what queries we actually run. So without going into a lot of complexity, the best I could do is point you to TPC-DS for that. So TPC-DS is an open standard set of queries that we're given as an industry to say, here, test all of these, and this will be an accurate comparison to the next person who tests it. So each one has a different level of complexity, and out of the I think it's 111 different queries. Each one you could go through on the TPC website. It'll tell you, to select from asterisk this, give you all the kind of breakdown of exactly each one of those queries.
Okay, thanks. Yeah, I might load something in between, but I didn't hear any support like the virtualization. So I'm also aware, I might be wrong, but there's a very close relation between EMC and the VMware.
Yeah,
virtualization is a hot topic in the enterprise world. So any play in the future, or it cannot be said much?
No, actually, I'd say today, I don't know the numbers yet on how much VMware has gotten into into environments. I think that today it's still a little bit lower numbers. My guess is that probably 5% or less of Hadoop clusters are virtualized. I will say that we've got some great customers that are already doing both virtualized Hadoop and putting it against a disaggregated Hadoop stack.
Yes.
And they've been really, really happy with the results. What is kind of interesting, if you just did a one-to-one virtualization to non-virtualized, it ends up usually being a little bit slower when you're virtualized. What we found is that the application of Hadoop, the actual apps on side, are not really optimized to use all of the processing power of the node. So when you get to a certain count, and we found that number to be 4 virtual machines inside of a physical compute node, all of a sudden it turns over, and I think it's between 30 and 70% faster per node by simply virtualizing 4 against the same physical box that you would have run Hadoop against in the first place. So we think it's just because we're now utilizing all of the actual processing power efficiently in the node by putting more horsepower against that particular processor.
Okay.
Thank you. All right, hey, thank you guys very much for joining me today. If there's any questions afterwards, thanks for coming up, and have a great rest of your time at Hadoop Summit.